In this video, we are going to be talking about the L'Hopital rule, that is the evaluation of limit of quotient, that is the limit in form of limit of x tends to a f of x divided by g of x. That is, we are going to be dealing with limits where x tends to a f of x of g of x, and most times we use this particular rule in solving for problems that are giving us undetermined answer or indeterminate answer or infinity answer. You understand? You understand what I'm trying to say? Like, for example, if we have something like if we have a problem like limit of x tends to 4, x minus 4 divided by x squared minus x minus 12 minus x, I'm coming, minus x minus 12. For example, you know that if you apply 4 into all of this, like we used to do, it becomes 4 minus 4 divided by 4 squared minus 4 minus 12. And that's going to be giving us what? That's going to be giving us 0 divided by 16 minus 4 minus 12. That will be equals to 0 divided by 0. And if you press your calculator, 0 divided by 0 is an undeterminate answer. It's an undefined answer. You understand? So how do we solve this? Remember that in one of our video where we talk about the limit of a function, where we can solve, we can use the concept of quadratic equation. You understand? And if we use the concept of quadratic equation, we are going to be factoring it into x minus 4 and x plus 3, right? Where this one cancel out this one, and we are going to be having 1 divided by x plus 3, if I can remember, and that will be equals to what? That will be equals to 1 divided by 6 finally in the final answer. But the truth is that we can actually solve this one without using quadratic equation, without the need of quadratic equation at all. 1 over 7, I meant 1 over 7. So we can solve this one easily without the need of quadratic equation. You understand? How can we solve it? We can apply the concept of what? We can apply the concept of L'Hopital rule, because using quadratic equation is going to take us longer time. You understand? What it's going to do is that L'Hopital rule says that you can continue to differentiate until you are not going to be having something that is going to give you 0 divided by 0. And that is the reason why I have to take the concept of differentiation first before we can move to the concept of L'Hopital rule. Let us take for an example. We have question like limit of x tends to 4, right? That is x minus 4 divided by x squared minus x minus 12, right? So what L'Hopital rule is saying is that I can differentiate both the numerator and the denominator. I'm not applying the quotient rule because there is a particular rule called the quotient rule. So don't mistake it together. If you are not having something like a limit at this side, we are going to be applying quotient rule to solve this particular question. But we are having a limit. We are saying that it is limited to a particular range, and that range is 4. You understand? So we can differentiate both the numerator and the denominator using the general rule of differentiation. You understand? Now, when we use quadratic equation, the answer that we got is 1 over 7. It means that when we are going to use L'Hopital rule, the answer that we must get is also 1 over 7. It's a must. You understand? Now, let us proceed. What it is going to do is that differentiate this numerator. If you differentiate the numerator, remember the general rule of differentiation. Ax raised power n equals to n ax n minus 1, right? And the differentiation of a constant number like 4 equals to 0. Therefore, I'm going to have what? I'm still having limit of x tends to 4, right? X becomes what? X becomes 1, because x is the same thing as x to the power 1, and that's 1 multiplied by x raised to the power 1 minus 1, and that's equals to 1 multiplied by x raised to the power 0, and that's equals to 1, which means if you differentiate ordinary x, you are going to be having 1. You understand? So that is equals to what? That's equals to, coming, that's equals to 1 x raised to the power 1 minus 1 minus 0, because 4 will become 0, minus 0. Then divided by, now let us differentiate the denominator. In differentiating the denominator, we are going to be having what? This 2 comes to the back, becomes 2x, 2 minus 1, minus this x becomes 1x raised to the power 1 minus 1, then minus 0, because differentiation of 12 becomes 0, right? We are still having limits of x tends to 4, right? Now, 1x power 1 minus 1 becomes 1x power 0, and that's equals to 1, right? So that is 1 divided by 2x power 2 minus 1 becomes ordinary 2x. And x power 1 minus 1 becomes what? Becomes minus 1. We have gotten this after differentiating. Now let us put this 4. Anywhere we see x, we are going to be putting 4. Therefore, we are going to be having 1 divided by 2 multiplied by 4 minus 1. And that's equals to 1 divided by 8 minus 1. That means our answer is 1 divided by what? 1 divided by 7. And that is our answer. Can you see that it is similar to when we use quadratic equation? Very, very simple and very, very easy. Now let's go another example. Let us take another example. We have something like limit of x tends to 3, then x minus 3 and x squared minus 9. You know that if we want to solve this and we put 3, that would be 3 minus 3 divided by 3 squared minus 9, and it's going to give us 0 divided by 0. Another alternative that I explained then is, what if we take the difference of 2 squared of this one, that it becomes x minus 3, x plus 3, and we are going to divide this one by this one. We are going to be having 1 divided by x plus 3, and that will be equals to 1 divided by 6. You understand? But we can also apply L'Hopital rule in this case to solve this particular problem. So let us say limit of x tends to 3, that is x minus 3 divided by x squared minus 9. So if we differentiate the numerator, we are going to be having 1. You know that that is x power 1 minus 0, 1 minus 1, and it equals to x power 0. And differentiation of 3 is equals to 0. So we're going to be having 1 minus 0 divided by, now this one becomes what? This one becomes 2x minus 0 as well. You understand? Therefore, my limit of x tends to 3 equals to 1 divided by 2x, right? 1 divided by 2x. And that will be giving us what? Whenever we put x, whenever we see 6, we're going to be having 1 divided by 2 multiplied by 3, and that's equals to 1 divided by 6, which is equals to, when we use this particular method. So L'Hopital rule is like just simply telling us that instead of using some other methods, we can actually use differentiation method in getting our answer. You understand? Let us look at another example. Let us say that limit of x, let us say that limit of x tends to 0, 6x minus sine x minus sine 2x minus sine 3x sine 3x, everything divided by x squared. X is power 3. X is power 3. Limit of x is to 0. Now, how are we going to do this? Remember that if you put 0 in all of this, wherever you see x, put 0. You are going to be having 6 multiplied by 0 minus sine x. That's sine 0 minus sine 2 multiplied by 0 minus sine 3 multiplied by 0 divided by 0 raised power 3. And our answer is going to be giving us what? That's going to be giving us 0 divided by 0, because sine 0 equals to 0. You understand? Sine 0 equals to 0. Y equals 0 equals to 1. You have to understand that. And even that one, we can use this method. Maybe I should quickly teach you that one. Angle, because you are going to be needing this one. Angle, sine, and cos. So let us say 0, 30, common angle, 0, 30, 45, 60, 0, 30, 45, 60, and 90. So for sine 0, that is 0 divided by, okay, I can say that root 0 divided by 2. This one is root 1. Sorry, 0 divided by root 2. This one is 1 divided by root 2. This one is, oh, this is how we can go about that. I'm coming. Let me quickly confirm. So this is supposed to be sorry, root 0 divided by 2. This one is going to be root 1 divided by 2. This one is going to be root 2 divided by 2. This one is going to be root 3 divided by 2. And this one is going to be root 4 divided by 2. divided by 2. And this one is going to be still root 4 divided by 2. This one is root 3 divided by 2. This one is root 2 divided by 2. This one is root 1 divided by 2. And this one is root 0 divided by 2. You understand? Which means cos 0, sine 0 equals to 0, while cos 0 equals to 1. You understand? Because root 2 divided by 2 is the same thing as 2 divided by 2. You understand? So that is how to go about that. That's just simply how to go about that. Now, if we differentiate all of this, we are going to be having what? We are going to be having 0 divided by 0 if we input 0 in all of this. Now, how do we use L'Hopital rule in explaining this? What you're just going to do is that differentiate. Differentiate until you are not having this x. You understand? We are not having this x at the what? At the downward part. Therefore, if you differentiate, this is x. So we're going to say that the limit of x tends to 0. This 6x becomes what? Becomes ordinary 6 minus this sine x becomes cos x. That is minus cos x. Then minus this sine x. You know it is sine 2x. And remember I mentioned that sine ax equals to a raised to power a sine ax. If you remember. Now that will become what? Which means sine 2x becomes what? Minus 2 sine 2x. Sine 3x also becomes minus 3 sine 3x. Everything divided by what? Everything divided by so we have something like this. So let us differentiate again. It's confusing. Okay, we said limit of x tends to 0. 6x becomes 6, right? Sine x becomes cos x. Then sine 2x becomes minus 2 cos 2x. Then sine 3x becomes 3 cos 3x. Everything divided by what? X raised power 3 becomes what? Becomes 3x raised power 2, right? Because if you differentiate x raised power 3 becomes what? It becomes 3x raised power 2, right? Now, if you look at it very well, if we still input 0, we are still going to be having 0 at the denominator, and anything divided by 0 equals to what? Equals to undefined answer, which means we are not there yet. We are still going to differentiate again. And let us keep differentiating. Now, in differentiating again, we are going to be having this 6 becomes 0. That will be 0 minus this cos x becomes what? Becomes minus sin x. That will be minus sin x. Then minus this 2 cos 2x becomes what? Becomes minus 2 multiplied by 2 sine 2x. Then this one become minus 3 multiplied by 3 sine 3x. Everything divided by what? If you differentiate this one, we're going to be having what? We are going to be having 6x. Now, why is it 2 multiplied by 2 sine 2x? Remember that cos ax equals to a cos x. So this 2 that is here will come and multiply the 2 that is here. You understand? Now, that will give us what? That will give us minus times minus becomes plus. That is sine x. Minus times minus, that is plus 4 sine 2x. Minus times minus, that is plus 9 sine 3x. Everything divided by what? Everything divided by 6x. See, everything divided by 6x. Now, if you input 0 in this one, we are still having 0 at the denominator, which means we are not there yet. We are still going to differentiate again. Now, in differentiating again, we are going to be having, we are still limit of x tends to 0. Now, sin x becomes what? Sin x becomes cos x plus 4 sine 2x becomes what? Becomes 8 sine 2x. Why? Because the 2 that is here will come multiply the 4 that is here. And 9 sine 3x becomes what? Sorry, it's supposed to be cos, not sine 2x. Cos 2x plus 9 multiplied by 3 is going to become what? Become 27 cos 3x everything divided by what? Everything divided by 6. So if you look at it very well, we have eliminated all the x that is at the denominator, which means if we input our x here, we are not going to have it at the denominator and we're not going to be having undefined answer. Therefore, that will be equals to what? We can now input 0. So we're going to be having cos 0 plus 8 cos 2 multiplied by 0 plus 27 cos 3 multiplied by 0, everything divided by 6. And that's equals to what? Now, look at what I wrote here. What is our cos 0? Cos 0 equals to root 4 over 2, which is same thing as 2 over 2, which equals to 1, which means cos 0 equals to 1. So whatever we say cos 0, 1 plus 2 multiplied by 0 equals to 0. So that is cos 0 as well. That is 8. Then 27 cos 0, that is equals to what? Plus 27. Everything divided by 6. And if you have all of this one together, you are going to be having 36 divided by 6. Therefore, our answer equals to 6. So that is how to apply L'Hopital rule, especially when you're having something about like you're having something like this. So you continue to differentiate, until you see that there is nothing that is going to be giving you 0 at the denominator. What you're just trying to avoid is that is 0 that is at the denominator. Try as much as possible to avoid that 0 at the denominator. You understand? So that is how to go about that. And in the next class, we are going to be talking about the product rule of differentiation, where we are going to be having if y equals to uv, therefore the y upon the x equals to u dv upon the x plus v du upon the x. This is the product rule. So in the next class, we are going to talk about how to apply this particular rule for differentiation. Thank you.